Hello and welcome to this video about vector space proofs. In this video we'll study the proof of this theorem, that adding this sort of vector to a set causes the set to remain linearly independent. I'll just slowly go through the statement of this proof. These proofs are starting to get more wordy, complicated and relying more on past proofs and definitions. So we'll start out with a set of linearly independent vectors called A, which contains n vectors, which are named this way, x1 to xn. Then we'll define this vector y to not be in the span of A, so that it can't be expressed as a linear combination of the vectors in A. So if we add this vector to this set, then the new set will still be linearly independent. And we can express it like this. This set A plus the new vector will be linearly independent. And we can also express it like this, as a set with vectors x1 to xn, and with the extra vector y, and I'll use this notation Li to say that it's linearly independent, as an abbreviation. So before doing the actual proof, we'll do a sort of sketch or strategy of how we'll do this proof. We'll start by writing out a vector that's in the span of A plus y, which is a linear combination of the vectors in this set, and we'll set it to be equal to 0 and try to solve for the constants c1 to cn and cy. And solving for them will force them to all be 0 to satisfy the condition for linear independence. So we'll start by using a proof by contradiction that this constant cy is 0. Then we'll use this to show that the other constants are 0, and therefore all of the constants are 0. So this is what we needed to show, and so this completes the proof. So let's start the proof. We're required to prove that setting this equation to be 0, which can stand for any vector in the span of A plus y, will give the solution that all of the constants will be 0, which satisfies the condition that the new set A plus y is linearly independent. We'll firstly show that cy is 0. We'll use a proof by contradiction. We'll suppose that it isn't 0. Then we'll solve for y as being a linear combination of the vectors in A. And this is what y is as a linear combination of the vectors in A. And therefore y is in the span of A. This contradicts our assumption that y wasn't in the span of A. And therefore this constant cy is 0, because setting it to be non-zero would cause a contradiction. Contradiction proofs may seem to be non-intuitive, but if we look carefully, having y not be in the span of A would force cy to be 0, because then it couldn't be expressed as a linear combination of the vectors in A. So now we can rewrite the vector like this, with a 0 being where the cy was. And we can remove this vector from the list. But this vector is in the span of A, and because A is linearly independent, then all of these constants are 0 as well. So we can say that all of the constants are 0. And this satisfies what we're trying to find at the beginning. So the set A plus y is linearly independent, and so we've completed the proof. And we can also write out the set like this. So I hope that you found this video to be helpful and educational. Please click like and subscribe if you did. Feel free to leave some helpful and constructive ideas and thoughts in the comments. Feel free to share this video, and thanks a lot for watching.